Good morning, GLA middle schoolers. It is Mr. Mehta here, and I am extremely excited to be here with you today. Today's date is what? Thursday, May 14th. That's going to be right. 2020. And I'm so excited to be here because we are starting our string of chemistry experiments. We have not one or two, but 4 chemistry experiments in a row that we're going to use to review the material that we've learned and have a bit of fun while we do it, leading into our unit test, which is 1 week from today, Thursday of next week. And today's experiment is a classic. It is this stuff called Oobleck. The word was first made up by Dr. Seuss, but we're going to make it in just a second. It's going to be super fun. I can't wait. Oobleck, before we jump into that, I do also want to give you a reminder about kind of where we're at in the schedule. This is not accurate anymore because that's from yesterday, but this is our calendar of the month that we're in, May 2020. Today's date is actually May 14th now, and we're doing experiment 1 today. Tomorrow you guys don't have science. I'm going to have experiments 2, 3, and 4 next week before our test. So if you think today's experiment looks cool and you're jealous and you're like, ah, darn, maybe I should have gotten the stuff to do these experiments after all, well, you still have experiments 2, 3, and 4 remaining, and here are the materials that you're going to need for that. Pause the video and write these down if you want to do them, because I want to keep moving forward to get to the experiment. Now today we are going to have do-nows and classwork questions, independent practice, and exit tickets just like normal, because we're doing this so that you can review and do well on the test. And in fact, your do-now is going to be even a little bit longer than normal, because we have a lot to review. So go ahead and take your science notebooks out. Give yourself a heading for today. It's Unit 6, Experiment 1, Oobleck. And we're going to actually have 10 do-now questions. I'm showing you the first 5 right now. So number 1 through 10, pause this video and answer these 5 do-now questions now. And then I'm going to switch to the next slide, and these are the next 5, questions 6 through 8. Pause the video again and answer these 5 do-now questions now. Alright, I'm now assuming that you've completed that, you've gotten all 10 questions answered, and you're going to check if you were correct. Number 1, anything that has weight and takes up space is called matter. That is the very first thing that we learned in our chemistry unit. Hopefully you didn't forget it, because we keep on using that term almost every lesson. Number 2, the 3 main states of matter are solid, liquid, and gas. Number 3, water that you pour in a drinking glass is in which state? Well, that's a liquid. You guys should know that. Number 4, ice cubes are in which state? They are solid. And 5, air that you blow into a balloon is in which state? Well, that is a gas. You should be pretty familiar with solids, liquids, and gases at this point. And 6 through 10 kind of expand on these ideas. True or false? Matter can change from one state to another. Well, that is true, because if water is a liquid and ice cubes are a solid, well, you can freeze water into ice cubes and you can melt ice cubes back into water. Number 7, if you could zoom in super close on any matter, you would see that it's really made up of tiny particles. That's that word that we were using for the first part of this unit. If you said atoms and molecules, then you should give yourself an extra big star, because that is the even more advanced and more correct answer, but particles works too for this one. Number 8, when the particles of matter hold each other together in a definite shape, it is a solid. Compared to number 9, when the particles of matter slide freely around each other, it's a liquid. And number 10, when the particles of matter can fly all over the place, it's a gas. So when you see things that are solid or liquid or gas, the reason that they are that state is really depending on what is going on with their particles at this kind of super microscopic scale that you'd have to zoom in really close to see. Just to recap again with some visuals, these are these 3 states that we've talked about: solids, liquids, and gases. You can see that when an object is solid, its particles are all clenched together holding its shape, which is why this ice cube stays cubic shaped even when it's just sitting on a flat platform. Whereas in the liquid, these particles are all kind of zooming around each other, and liquid spreads out and takes the shape of the container that it's in. Whereas in gases, the particles are moving around crazy fast, and gases expand and take up as much space as they can. We looked a lot at this little moving animation. It's showing you the same idea, but it's just moving so that you can see it better, right? See the gas particles bouncing around like crazy, the liquid particles kind of swimming amongst each other, and the solid particles just holding in place right there. Now, while we were going through these states of matter, what I wondered when I was like a 5th grader all the way back in science class back in the day, and what I'm sure a lot of you are wondering, is this question. What state of matter is Play-Doh or slime? Are there some things that are in between 2 states of matter, right? Because you can probably think of a whole bunch of these kind of slimy or goopy objects around the world that are maybe kind of in between a solid and a liquid, like honey or ketchup or something like that, right? Is matter always just in one of these 3 categories? Well, Scientists do their best. They try to have clear rules about states of matter that put it clearly into one category or another, and these are the rules that they use. So the way that they define a solid, something officially, in order to be solid, solids hold their own shape. What that means is that a solid ice cube, or a solid cube of ice, stays cube-shaped no matter what container you put it in. So this ice cube stays cube-shaped. I mean, unless you smash it or something, but just putting it into a different container isn't going to change the fact that it's shaped like a cube. Compare that to a liquid. Liquids are defined by the fact that they take on the shape of their container. So, looking here, we see that liquid water poured in a circular glass becomes circle-shaped itself. So this glass, right, is kind of the shape of a circle, or really you would say a cylinder. And when you pour the water into it, the water just fills up all of that space, and now the water is also, you have like a cylinder of water because it's in a cylinder-shaped glass. That's why it's a liquid. And lastly, gases. Gases have no definite shape. Water vapor gas just kind of expands to fill whatever space it has. Even their volume can change. If you have a gas and you release it into an open space, it expands in its volume and it spreads out to take up as much space as it has. These are the rules scientists try to use to say, okay, officially what's a solid, what's a liquid, and what's a gas. But some materials, they don't play by the rules. And there's a name for these kinds of materials that don't fit neatly into these categories. They call them non-Newtonian fluids. That's how you pronounce that word. Try pronouncing it yourself. Non-Newtonian fluids. Alright, I'm sure you said it great. We are going to be messing around with one of these non-Newtonian fluids today, called Oobleck, and we're going to jump to the experiment now. Check it out. I recorded this just a second ago. Hopefully we can hear me loud and clear. Here we are. Alright, ladies and gents, we are ready to go. We're going to knock off the first of what will be 4 chemistry experiments to round out this unit and help us review the stuff we've been learning before our unit test. Like I said, today, we're making Oobleck. Oobleck is an example of a non-Newtonian fluid. That means it's something that's sometimes a solid and sometimes a liquid, not depending on its temperature, but depending on how stressed versus relaxed it kind of is in any moment. We'll see what that means when we get to actually making it. Now, most things in the world are pretty clear about whether they're a solid, a liquid, or a gas. And when they change in between those 3 things, it's because of their temperature. For example, water, right? In this glass, I have both some liquid water, that's at room temperature, and I have some frozen ice in the form of an ice cube that is very cold. And it's pretty clear that one of them is solid and one of them is liquid because the solid one keeps its shape. This ice cube stays ice cube shaped even though it's in a glass of water, whereas the water just kind of becomes the same shape as the glass, the liquid water, because it's a liquid and that's what liquids do. Scientists try to use that rule, does it have its own shape or does it take the shape of its container, to tell whether something is a solid or a liquid most of the time, but then we have this weird stuff like Oobleck that has kind of different rules that it plays by. Alright, let's get to the actual experiment. What you're going to need is, first of all, a good workspace. This experiment will be a little bit messy, warning to parents. So you want to either lay down a whole bunch of newspapers, or like for me, I've got this big tray that I can work with. You're going to have an actual bowl where you're going to make your Oobleck itself, and then your supplies for the day are going to be some water, room temperature, whatever temperature you like, some cornstarch, thank you Mom, and optional, some food coloring. I have green food coloring because I like the color green. The food coloring is optional. It doesn't actually affect what's going on. It just makes it look cooler. There's a slight chance, parents, that maybe if you use the food coloring that could stain some things, so maybe you want to be a bit more hands-on. And also some measuring cups. I have here a 1 cup measure and a 1/2 cup measure. Now to make Oobleck, all you have to do is mix together water and cornstarch. And the ratio, it doesn't have to be exact, but you're going to use about You're going to use about twice as much cornstarch as you use water. So I'm going to start off with my 1/2 cup measure and fill that full of water. It's not an exact science, but we're going to use about 2 to 1 cornstarch to water. Then I'm going to go ahead and mix in my food coloring first, so that the food coloring spreads out, and because it's just kind of cool to watch it. Other warning that I will give, because I did this experiment just a minute ago, and I used blue food coloring, and it did turn one of my hands faintly blue. So that is maybe a risk at hand if you're deciding whether or not to use the food coloring. Just be careful with it. And I'm going to stir it up. So basically all we have right here is some green water. Regular old water with green food coloring in it. And then I'm going to take my cornstarch and I'm going to pour it into my 1 cup measure and add it to my water and start mixing it around to make today's Oobleck. Come on, you. Cooperate with me. There we go. Alright. And again, it doesn't have to be perfect. We're going to start with about 2 to 1, though, and we'll adjust it if need be. Now, I'm going to pick my right hand to be my stirring hand, which means my right hand is going to get messy, and try to keep my left hand clean for as long as I can. But I just want to take this cornstarch and start spreading it out into the water and doing my best to mix it in. Now, as you start mixing, you're going to notice that it starts to feel kind of weird, and it kind of makes itself difficult to mix once you start getting that cornstarch and water combined. That is because of the properties of Oobleck that we're about to be learning about. You can't really, if you try to just stir it, it almost like it gets kind of solid and it blocks you and it gets in your way. And we will see why in just a second. So just take your time. You can be patient. Do what you can to try to get these two things combined. There's not really any rush. But you want to try to get rid of all of the solid clumps of cornstarch and mix them with the really liquidy parts of the water. And after a while, what you will find starts to form is your Oobleck. Like I said, yes, this experiment is a bit messy. Alright. I'm just trying to spread the cornstarch out evenly inside as much as I can. And I'm feeling pretty good about this. Now, so far, if you're just watching this and you're not trying it at home, you might be wondering what is so special about this? Why is this such a cool experiment? Because you can't feel this stuff. This stuff feels really weird. And what feels weird about it is that it's constantly going back and forth between being a solid and a liquid. So, for example, if I try to hit it really quickly, I can't get my fingers all the way down to the bottom of the bowl. It turns solid when I try to hit it. When I try to be mean to it, or stress it, you could say. But if I just let my fingers be really gentle and kind of slowly press into it, I can press all the way through down into the bottom of the bowl. But I can't do that same thing if I try to go really fast and I just hit it. It tenses up and freezes. Now watch this. I can try to slowly start gathering up some of the Oobleck that I have. Let's see if I'll be able to do this today. And if I move quick enough, actually, I can start to kind of gather it. Yeah, I'm going to add some more cornstarch. I want mine to be a little bit more solid than it is right now. Keep mixing that in. Yes, I can. Man, this stuff does feel weird. You guys got to try this at home. It's really bizarre. Alright, I've got some more cornstarch in here now. And now I can try to show you. If I move quickly, I can kind of get a handful of this stuff to gather together and actually act as a little ball. And as long as I keep it moving and I keep pressing on it and squeezing it, it stays pretty solid. Man, I better not get any of this on my computer. Now, I can't pause to show you, but as you can hopefully see from the way I'm handling this right here, it's pretty solid. It's almost like a ball. I'm tempted to try to bounce it or something. But the weird thing with this stuff is, as soon as I stop moving it and I relax, it turns right back into a liquid again, and it seeps through my fingers. That is what is so cool about Oobleck, and why I recommend you guys try making some of this stuff at home and seeing what it really feels like. Oobleck is constantly going back and forth between being a solid and a liquid. And as soon as you try to hit it suddenly or forcefully, it turns solid. But as long as you're gentle and you're slow with it, it acts as a liquid. And it's one of the weirdest feeling things on the world. It doesn't just, I mean, I know a lot of people play with slime these days. It doesn't just feel like normal slime. It has its own kind of feeling. I'm going to try one more time to scoop up as much as I can. And you have to intentionally be rough to do that, to try to get a big handful. Oh my god! I got this big ball full of it, and it's acting mostly solid as long as I keep moving. But then as soon as I relax it, look at that. It's a liquid all over again. Alright, that is my Oobleck experiment. I highly encourage you to try it at home, just to feel it, to play around with it, maybe go outside. I highly discourage you from trying to throw it at somebody, even if it feels like you have a nice solid clump, because it's just going to turn back to a liquid and get everything all gross again. But it's definitely worth giving a shot and feeling for yourself. Again, we call these kinds of fluids that change back and forth between different states non-Newtonian fluids. And Oobleck does it really well. It goes from like totally solid to totally liquid, so it's a really good non-Newtonian fluid. But there actually are non-Newtonian fluids all around you in your life. For example, ketchup is slightly a non-Newtonian fluid. That's why when you shake a ketchup bottle really hard, it tends to pour easier because it kind of liquefies out. But when it holds still, it can be more of a solid. I believe honey is a non-Newtonian fluid. Blood is slightly a non-Newtonian fluid. A lot of shampoos are. They change back and forth between solid and liquid based on how stressed they are. Alright, I'm sorry. If I keep going like this, I'm going to be playing with this stuff all day. I'm going to cut the video right there. Back to you, Mr. Manta. Well, thank you so much, Mr. Manta. There was our demonstration, folks. Experiment number 1. Just to recap what we saw really quickly, these things are called non-Newtonian fluids. And they were named after this fella right here, Isaac Newton, because Isaac Newton figured out what the rules were for how most fluids behave, and then these were the exceptions to his rules that made them non-Newtonian fluids. Here we go. Oobleck is an example of a non-Newtonian fluid. This means that it changes how liquid or solid it is depending on whether you stress and exert force on it. Specifically with Oobleck, when you force it or move it quickly, it turns solid, but when you let it relax, it turns liquid instead. Lots of liquids around you are also non-Newtonian fluids. This isn't the only one, but Oobleck, most of them don't change as much as Oobleck. It changes, like, it feels really solid when you try to hit it and really liquid when you let it seep through your fingers. But some other examples, like I said, were honey, toothpaste, paint, shampoo, and in addition to human blood. There you go. You have a non-Newtonian fluid inside of you all the time. Alright, at that point, that's going to bring us to these two classwork questions, number 1 and 2. The first one, what are some other things you can think of that you suspect might be non-Newtonian fluids? Name at least 2. You don't have to be right for sure, but things that you would guess, maybe Plato isn't something right, something like that. Try to guess at least 2 of them. And classwork question number 2, imagine that you are a material scientist, and you invent a new material that can change between solid, liquid, and gas instantly. What's one way this might be useful to people's lives? What's something that you could use that invention for to help people? Try to think of a good answer for that. I'm curious what kind of crazy ideas you guys come up with. Alright, pause this video and answer these 2 classwork questions now. Alright, I'm assuming that we are now unpausing and moving forward, and we've gotten to the independent practice section of our class today. We actually have 10 independent practice questions, so make sure to number your notebook 1 through 10, and here are the first 5. This is from the beginning of today's PowerPoint, in addition to some older stuff as well. Pause this video and answer these 5 independent practice questions now. Alright, I'm assuming that you've done that now. Numbers 6 through 10 are here. Pause the video again and answer these 5 questions now. Alright, and let's see some answers. First off, we're looking at numbers 1 through 5. Scientists define solids as matter that holds its own shape. Like, for example, staying in the shape of an ice cube, or my desk stays desk-shaped all the time, right? Number 2, scientists define liquids as matter that takes on the shape of its container. So if I put water into a square glass, the liquid water becomes kind of square-shaped. But if I put it into a circular glass, it becomes circular-shaped. Number 3, how do scientists define gases? Well, gases are ones that have no definite shape. Or, and this is B for special extra advanced, extra credit maybe, they also have no definite volume compared to liquids and gas and solids, which solids have definite shapes and liquids at least have definite volumes. But that's a little more advanced than we need it to be. Number 4, Oobleck is an example of a non-Newtonian fluid, that's what we call these things, because it changes how solid or liquid it is. And number 5, when you squeeze or stress Oobleck, it turns solid. When you let it relax, it turns liquid. We saw that demonstration ourselves. And numbers 6 through 10, anything that has weight and takes up space is called matter. 7, matter is solid when its particles hold together in a definite shape. Number 8, matter is liquid when its particles can flow freely around each other. Number 9, matter is gas when its particles can fly all over the place. And for number 10, we brought in some recent concepts as well. A solid ice cube melts into liquid water. Is that a physical change or a chemical change, and why? Well, that is going to be an example of a physical change because no new substance was created. You just had solid water and it turned into liquid water, but it's still water. When things change their state, it's always going to be a physical change. Alright, go ahead as always, star those ones you got right, fix the answers you got wrong, and tell me which are which in the classwork form. ladies and gents, that's all we got for today. That brings us to exit ticket time, and hopefully for many of you, time for you to now go and do the experiment yourselves. Now, of course, if you are doing the experiment yourself, number one, you need to have parent supervision, and number two, please, please, please take pictures and videos and send them to me. And I will feature all the videos that I get in next week's experiments. And man, if someone does all 4 of the experiments, I gotta think long and hard about what kind of special prize I'm gonna be able to give them. That's all we got for today. Today's cool thing is a video from our friends, the Mythbusters. They tested a myth a long time ago about whether or not it could ever be possible to walk on water. And one idea they had was to turn their water into Oobleck. So they made a giant vat of the stuff, and Adam tested whether or not he could walk and run and jump across it. It's a pretty cool video. Take a look at it in the link for today's cool thing. Alright, that's all we got for today. Take care, folks, and I will see you, on Monday.